Hello, everyone, and a very warm welcome to this journey with me today. Before we begin, I want to take a moment to send my very best wishes to you and your loved ones. Wherever you are in the world, I truly hope you are happy, healthy, and in good spirits. Let's dive into something truly incredible together. Imagine a place so utterly different from anywhere else on Earth that it feels like another planet entirely. A land of breathtaking, silent beauty and extreme, unimaginable power. A continent of pure white that stretches further than the eye can see, under skies that can be brilliantly clear or ferociously violent. This is Antarctica. It is a place of superlatives, of ultimate extremes. It is the coldest place on our planet, the windiest place, and, perhaps most surprisingly of all, the driest place on Earth. When we think of dry deserts, our minds usually conjure images of vast, rolling sand dunes under a blistering sun, like the Sahara. But by the scientific definition of a desert, a region that receives very little precipitation, Antarctica is the largest desert in the world. It is a polar desert, a continent of ice that is, in its heart, as dry as any dust-blown landscape. The cold here is not just the cold of a winter's day. It is a deep, profound, and ancient cold that has existed for millions of years. The wind is not a gentle breeze. It is a katabatic force, a river of dense, frigid air pouring off the high ice sheets with the speed and roar of a freight train, capable of shaping the land itself. To understand Antarctica is to understand the limits of life and the incredible power of our natural world. It is a crucial component of Earth's climate system, a reflector of solar heat, a freezer of ancient air, and a driver of global ocean currents. What happens in Antarctica does not stay in Antarctica. It affects every single one of us, no matter how far away we live. So, let's pack our warmest virtual gear and embark on an exploration of this magnificent, frozen continent. We'll unravel its secrets, meet its unique inhabitants, and discover why this seemingly empty wilderness is so vitally important to the past, present, and future of our world. The story of Antarctica begins not with ice, but with fire and forests. It's almost impossible to picture it now, but this frozen continent was once part of a giant supercontinent called Gondwana, snuggled up close to what is now South America, Africa, Australia, and India. It was a much warmer place, covered in lush green forests and inhabited by dinosaurs and, later, a wide array of mammals. You could have walked from Australia to Antarctica through dense vegetation. This warm past is etched into the very rock of the Transantarctic Mountains, where fossilized trees and the bones of ancient creatures have been discovered, telling a silent story of a world long gone. The journey to its current frozen state started tens of millions of years ago as the tectonic plates slowly, inexorably, pulled apart. Gondwana broke up and Antarctica, carrying its cargo of life, drifted southwards, alone and isolated. It settled directly over the South Pole, and as the continents moved, great ocean currents began to circulate around it unimpeded. This current, the Antarctic Circumpolar Current, became the planet's most powerful ocean flow, a relentless river of water that completely isolated the continent from the warmer waters to the north. It created a thermal barrier, a moat of cold that locked Antarctica into a deep freeze. The temperature began to drop and drop and drop. The lush forests died out, and the ice began to form. It started with glaciers in the mountain ranges, which grew and flowed and merged, eventually swallowing the entire continent in a single, massive sheet of ice. This ice sheet is not a static thing. It is dynamic, always slowly flowing from the center of the continent out towards the coasts under its own immense weight. This process took millions of years, creating the Antarctica we know today, a continent buried under ice that averages over 2 kilometers thick. In some places, this ice is so deep it buries entire mountain ranges, hiding landscapes that no human has ever laid eyes on. This ice is the key to everything. It is the heart of the continent, its defining feature, and its most valuable treasure. It contains within it a record of Earth's climate stretching back over 1 million years. Trapped in tiny bubbles within the ice are samples of the ancient atmosphere, allowing scientists to read the history of our planet's air like pages in a book. The weight of the ice is so colossal that it has actually pressed the bedrock of the continent down, depressing it deep into the Earth's mantle. If by some magic all the ice were to instantly vanish, the continent would actually spring back upwards over thousands of years in a process called isostatic rebound. But the ice is not vanishing. It is, however, changing, and that change is a story for later. Now, let's talk about that famous cold. Why is it so incredibly cold? The primary reason is its position over the South Pole. Because of the Earth's curvature and tilt, the sunlight that reaches Antarctica arrives at a very low angle. It's like trying to warm yourself with a flashlight beam shining almost parallel to the ground. It spreads its energy over a much larger area and has to travel through more of the atmosphere, so it provides very little heat. This is in stark contrast to the equator, where the sun's rays hit directly, concentrating their energy. But then, for half the year, the sun doesn't show up at all. The long, dark Antarctic winter is a time of ultimate cold. Without any solar input for months, the land just radiates its remaining heat out into space. The temperature plummets and doesn't recover. It creates a permanent reservoir of cold air over the center of the continent. This cold air is incredibly dense and heavy. And this is where the wind comes in. Antarctica is not a flat pancake, it's dome-shaped, with the highest, coldest points in the center. This heavy, dense air wants to do one thing: flow downhill, pulled by gravity. But it's not flowing down a gentle slope like water, it's flowing down the immense, gradual slope of the ice sheet. As it accelerates, it gets funneled through valleys and between mountains, picking up tremendous speed. These are the katabatic winds. They are not storms, they are a fundamental feature of the Antarctic climate. They can blow for days and weeks on end, reaching speeds that are hurricane force. They are the reason that simply setting up a tent in many parts of Antarctica is a serious engineering challenge. The wind can shred fabric, tear structures apart, and sculpt the snow into hard, sharp formations called sastrugi, making travel incredibly difficult. The wind also contributes to the dryness. Cold air can hold very little moisture. When this katabatic wind blows off the plateau, it is already extremely dry, and as it descends and compresses, it warms up slightly, but this is a warming that further reduces its relative humidity, making it a desiccating force that can suck the moisture right out of any exposed surface. This is why the McMurdo dry valleys exist. This is one of the most bizarre and fascinating places on Earth. Located in Victoria Land, these valleys are largely free of snow and ice, because the katabatic winds are so fierce and constant that they scour away any moisture. The ground is bare rock and gravel, and it contains glaciers that are not melting from the sun but are instead sublimating, turning directly from solid ice into water vapor because the air is so dry. The conditions here are the closest thing on Earth to the surface of Mars, and scientists study them intensely to understand how life might, or might not, exist on other planets. So, the cold and the wind work in a vicious, self-reinforcing cycle to create the harshest environment on our planet. But a continent of just ice and rock would be remarkable enough. What makes Antarctica truly magical is the life that clings to its edges and fills the ocean that surrounds it. The interior of the continent is largely devoid of life. There are no trees, no shrubs, no grasses. There are no large land animals like polar bears. This is a common misconception. The land is dominated by microbes, tiny invertebrates like springtails and mites, and the incredibly hardy lichens that can grow on sun-warmed rocks. The real explosion of life is in the Southern Ocean. The very same current that isolated Antarctica and made it so cold, the Antarctic Circumpolar Current, is also the reason the ocean is so rich with life. It churns the water, pulling up nutrients from the deep ocean floor towards the surface. When the long winter night ends and the sun returns, it provides the energy for microscopic plants called phytoplankton to bloom in unimaginable numbers. This phytoplankton is the foundation of the entire Antarctic food web. It is eaten by tiny shrimp-like creatures called krill. And krill are, without exaggeration, the keystone species for the entire Antarctic ecosystem. They swarm in trillions, their combined biomass outweighing that of the entire human population on Earth. These krill are the primary food source for almost everything else. They are eaten by fish, which are eaten by seals and penguins. They are filtered directly out of the water by great baleen whales. A single blue whale, the largest animal to have ever lived on Earth, can consume several tons of krill in a single day. The ocean around Antarctica is a bustling, thriving, noisy metropolis of life. The coastlines and pack ice are home to iconic animals that have become symbols of the continent. Penguins are the most famous residents. They are not the cute, tame creatures of cartoons. They are tough, resilient, and highly evolved birds that have traded flight for incredible swimming prowess. Their feathers are incredibly dense, waterproof, and windproof, and a layer of blubber keeps them warm in the freezing water. They gather in colossal colonies of hundreds of thousands of individuals, a chaotic and smelly but wonderfully social scene. The air is filled with their cacophony of calls as parents find their chicks among the crowd. Then there are the seals. Several species call these waters home, from the powerful leopard seal, a top predator that hunts penguins and other seals, to the enormous elephant seal, to the curious Weddell seal, which can use its teeth to grind holes in the ice to breathe and is known for its eerie, sci-fi-like calls underwater. And soaring above it all are the seabirds, the majestic wandering albatross, with the longest wingspan of any bird, which can glide for thousands of miles without ever flapping its wings, and the feisty skuas, which are not afraid to steal a penguin egg or dive bomb a scientist who gets too close to their nest. This rich ecosystem is a delicate balance, perfectly tuned to the extreme conditions. It is a reminder that life is not just persistent, it can flourish in the most unlikely of places when given the chance. Humanity's relationship with Antarctica is a very recent and dramatic chapter in its long history. For centuries, it was a land of myth, a hypothetical terra australis incognita, the unknown southern land that cartographers thought must exist to balance out the land masses in the north. The first confirmed sighting of the mainland didn't occur until 1820, and it was followed by the famous, heroic age of exploration in the early 20th century. Names like Robert Falcon Scott, Ernest Shackleton, and Roald Amundsen became legend. These men and their crews sailed in wooden ships into the unknown, facing unimaginable hardships. Their stories are epic tales of courage, endurance, and sometimes tragedy as they race to be the first to reach the South Pole. Amundsen, using dog teams and well-planned supply depots, won the race in December 1911. Scott's team reached the pole a month later, only to find the Norwegian flag, and tragically perished on the return journey. Shackleton's failed attempt to cross the continent became one of the greatest survival stories ever told, as he led his entire crew to safety after their ship, the Endurance, was crushed and sunk by pack ice. These explorers revealed the continent to the world, not as a habitable place, but as a testing ground for human spirit. After World War II, the scientific value of Antarctica became clear. The International Geophysical Year in 1957 to 58 was a pivotal moment, where scientists from many nations worked together in a spirit of cooperation. This led directly to the Antarctic Treaty, signed in 1959, which is a truly extraordinary document in human history. It sets aside Antarctica as a continent dedicated to peace and scientific research. It froze all territorial claims, meaning no country can assert ownership over any part of it. It prohibits any military activity, nuclear testing, and the disposal of radioactive waste. It is a shining example of how nations can come together to protect a global commons for the benefit of all humankind. Today, human presence is made up of scientists and support staff living in research stations. These stations range from the large and almost town-like American base at McMurdo, which can house over 1,000 people in the summer, to small, remote outposts with just a handful of occupants during the winter. Life there is a blend of high-tech science and basic survival. Everyone is there to support the science, which is incredibly diverse. Glaciologists drill deep ice cores to study past climate. Astronomers set up telescopes because the cold, dry, clear air offers some of the best viewing conditions in the world. Biologists study the unique adaptations of the animals. Geophysicists listen for earthquakes and study the rocks deep beneath the ice. They live in a close-knit community, completely dependent on each other and on supplies shipped or flown in from the outside world. The winter, with its months of darkness, is a particular psychological challenge, a test of isolation and confinement that is also studied as an analog for long-duration space missions to Mars. So, the human story of Antarctica has evolved from one of conquest to one of custodianship, a continuous effort to understand this place so we can better understand our entire planet. This brings us to the most critical and urgent chapter of Antarctica's story, its role in our changing climate. Antarctica is not a remote, frozen museum. It is an active, dynamic player in the Earth's climate system, and it is responding to global warming in ways that are profound and deeply concerning. The continent has two main ice sheets: the East Antarctic ice sheet, which is larger and more stable, resting on bedrock above sea level, and the West Antarctic ice sheet, which is smaller but far more vulnerable because much of it rests on bedrock that is far below sea level. Think of it like this. If an ice sheet is on land, like a mountain, it's relatively stable. But if an ice sheet is sitting in a bowl that is below the ocean, warm ocean water can sneak underneath it, melting it from below and loosening its grip on the bedrock. This is what is happening in West Antarctica. The warming of the Southern Ocean is causing glaciers like the Thwaites Glacier, often called the Doomsday Glacier, to melt and retreat at an accelerating rate. This is a process that can become self-sustaining through a mechanism called marine ice cliff instability. As the glacier retreats, it exposes taller and taller cliffs of ice facing the ocean. Ice is not structurally strong enough to support very tall cliffs, so these cliffs can collapse catastrophically, further accelerating the glacier's retreat. This is not a future possibility. Satellite measurements show this is happening now. The Antarctic Peninsula, the long finger of land that points towards South America, is one of the fastest warming places on Earth. Here, vast ice shelves, the floating extensions of glaciers that flow off the land, are disintegrating. The Larsen A and B ice shelves collapsed in 1995 and 2002, respectively. In 2017, a gigantic iceberg the size of the state of Delaware broke off from the Larsen C ice shelf. While this doesn't directly raise sea levels, ice shelves are already floating, like an ice cube in a glass. Their loss is critical because they act like a cork in a bottle, holding back the glaciers on land. Once the ice shelf is gone, the glaciers behind it can flow much faster into the ocean, which does directly contribute to sea level rise. And sea level rise is the global consequence of Antarctic melting. The ice locked away on the Antarctic continent holds about 60% of the world's fresh water. If it all were to melt, a process that would take many centuries, it would raise global sea levels by nearly 60 meters. Even a small fraction of that melt would be catastrophic for coastal cities and communities around the world. But the impact isn't just about sea level. The meltwater from the ice sheets is fresh water, and as it pours into the Southern Ocean, it is changing the salinity and density of the water. This can potentially disrupt the Great Global Ocean Conveyor Belt, the system of currents that circulates heat and nutrients around the planet, which could alter weather patterns worldwide. So, the changes in Antarctica are a ticking clock for the entire world. Scientists are there in a race against time, using satellites, airplanes, robots, and ground teams to measure the changes, to improve our models, and to understand how fast the ice will melt. Their work is no longer just about curiosity. It is about providing the world with the information it needs to prepare for the future. Antarctica, in the end, is a continent of paradox. It is a place of immense silence, yet its ice holds a noisy record of Earth's past. It is the most barren desert, yet its surrounding seas are among the most teeming with life. It is a place that seems utterly separate from our daily lives, yet its fate is inextricably linked to our own. It represents both the ultimate power of nature and its profound fragility. The heroic explorers of the past saw it as a challenge to be conquered, but we now understand it is a treasure to be protected. The Antarctic Treaty System, with its protocols on environmental protection, shows that humanity is capable of collective, long-sighted action. It is a symbol of international cooperation and peace. But the new challenge of climate change is testing that spirit like never before. The decisions we make today about energy, about emissions, about our consumption, will directly influence how much ice melts, how much the seas rise, and how the incredible ecosystem of the Southern Ocean will fare. Antarctica is our planet's early warning system. It is sending us a message, written in the calving of glaciers, the retreat of ice shelves, and the changing patterns of life. It is a message we cannot afford to ignore. It reminds us of the breathtaking beauty of the natural world and the responsibility we all share as its stewards. It is a continent that belongs to no single nation, but to all of humanity and to every living creature that depends on the stable climate it helps to regulate. So, the next time you see a picture of a penguin, or a glacier, or a vast white landscape, remember that it is not just a faraway place. It is a vital part of our world, a keeper of our past, and a messenger of our future. It is a reminder of what we stand to lose and what we must fight to preserve. Thank you for joining me on this journey to the bottom of the world. Take care, be well, and I'll see you in the next one.